chapter we are going to discuss about the WAN technologies. So let us try and understand the need of WAN technologies here. So consider this is one LAN segment, LAN 1, this is another LAN segment, LAN 2, and the distance between this LAN 1 and LAN 2 is approx, let's say, 1000 kilometer or maybe more than that. So whenever it comes to the distance here as 1000 kilometer to connect your LAN 1 to LAN 2 segment, we are not going to have our own physical cable and connect together, never. So just to provide the connectivity between these two LAN segment itself, we are going to use the technologies called as WAN technologies. That's nothing but your WAN technologies. In simple term, we are going to take the help of your service provider, and they are basically providing the services to connect your one LAN to another LANs. For example, at your premise you will have your dial-up modems. Service providers will have their own devices, for example CSU and DSU. Like that, there will be many more devices available in the service provider network. So make sure we are not here to understand the actual service provider network. We are here to understand what is the need of your WAN actually. So make sure your WAN connection is all about to connect your different LAN segment itself. For example, if the distance is more, maybe 1000 kilometer or 2000 kilometer between them, you'll be able to connect them. It is just an example. Now let us try and understand the different type of WAN technologies which is available in the market itself. So the type of network could be your enterprise access. Enterprise access in the sense is a kind of private access, or internet access as a public network access itself. And again, there are further classifications you will get in the enterprise and the internet access as well. For example, see, as we discussed, the WAN technologies has the two major, enterprise and the internet. So enterprise is basically considered as your private, and the internet is basically considered as your public. In private, you have the connections like dedicated connections here, and you can find the switched network as well. So in dedicated, the most popular what we knows that is lease line, and the line connections could be E1 or maybe T1 or E3 or T3 you'll be getting. When it comes to your switch network, you can have the circuit switching or you can have the packet switchings as well. So when it comes to circuit switching, you have the PSDN and ISDN network, and the packet switching, which is basically your Metro Ethernet, MPLS, frame relay technologies you have. Like that, when it comes to your public network, it's nothing but your internet itself, where over the broadband or VPN you'll be able to use it, and the technology what we the services what we use as DSL cables and wireless technologies you have. Make sure there are many technologies which is outdated from this list. We are not using it, but just to understand it is very much important to know that. For example, PSD and ISDN connections are not there. You do not have any frame relay, you do not have any ATM type of connections. So you have the specific things to know that WAN technologies are basically used to connect your two different LAN segments when the distance is more. For example, let's take an example of one more. Let's say, as we have already discussed, that you can have the routers to connect your different offices. For example, let's say this is your one router, this is your another router, and consider this is your router 1 and router 2, and now see the distance is between these two routers maybe just 1 meter or 2 meter itself. They are present in the same office. Let's say we are trying to perform our demo, so definitely we need to keep our routers closest to each other so that you will be able to connect all together. So what happens here, when the distance is less between your routers, you can directly go ahead and connect your routers physically together by using one of the cable, which is basically known as serial cable or V.35 cable. Serial cable or V.35 cable. When the routers are closest to each other, let's say it is in your office itself, you will be able to connect like this. It is just like this. If you see the scenario, it is like this is one router, this is another routers, and this router, let's say, present for your LAN segment 1, and this is presenting your LAN segment 2. Now to connect your two different LAN segment where the distance is, let's say, your 1000 kilometer itself. So just to connect this, now you are going to have the WAN technologies in the picture. So here you will have the connections from here, you will have the connections from here, and service provider is already spread across the globe. So now you are going to connect your one router to another router, and you are going to have the communications here. So service provider is coming into the picture in this case when the distance is more. But let's say if the routers are present into your office itself and you are trying to connect together, so you are just going to take one special cable which is known as serial cable and connect to your routers. Right now your WAN technologies has been replaced with one of the serial cable in this, but make sure this is just for your demo purpose, just to understand the concepts. But in the real time you will find the wide area network type of connection itself. I mean the service provider networks always. Now couple of things to remember in this. Again, some major points. So the major points to remember is the WAN technologies. Of course you have the WAN technologies, but there are some different kind of topologies you will find in the WAN technologies which we need to understand. Okay, so let us try and understand this different kind of WAN technologies topology or its connectivity type. So first of all, we'll take a scenario. See, the scenario is very simple. Let's say this is one office. I'll have the different scenario here in this. See, so right now consider this is head office, and this is your branch office 1 and branch office 2 and branch office 3. Now to connect all the offices together, I am going to use the special technologies which is nothing but my service provider network, which is WAN technologies. Now say, consider first I am going to connect, make sure the physical connectivity will be there between the head office and WAN technologies always. For example, it is connected to this is also connected to this, physically they are connected together like this. Now you need to make sure the connectivity, the logical connectivity between your offices together. For example, when I go ahead and connect the offices like this, let's say I am going to have the connections from here to here. I am going to have one more connection, let's say from here to here, and from here to here, like this. This kind of connections, this is basically a kind of topologies which is considered as the hub and spoke topology. Hub and spoke topology, where this will be considered as hub and these all are considered as the different spoke here. Hub and spoke topology. Right now to reach head offices, all the branch offices can go directly. But think about when the branch office 1 trying to communicate with branch office 3, your request has to go here and then it has to go here. Similarly, when branch office 2 wants to communicate with branch office 1, your request has to go here and then it has to come back. So in some cases you may go ahead and have the direct connectivity as well. For example, I want my branch office 1 should be able to communicate with branch office 2 directly. In the sense, I am going to have one more virtual type of connections from here to here. Say this. So right now branch office 1 can communicate with branch office 2 directly. It can communicate with head office as well. So right now when you consider this particular scenario, you see only one branch office is left over. When it comes to branch office 1, 2 and head office, they are fully connected to each other. So this type of topologies is basically considered as partial mesh. This type of topology is considered as partial mesh. And we have already discussed this kind of scenario in our previous lectures as well. Now say for example, what if I want the connectivity of all together? For example, I want this branch office 3 should be able to communicate with branch office 2 directly. So you can have the connections like this, and I can have the connections like this. See, means all the offices are interconnected to each other. And this kind of topology is basically known as your full mesh topologies. This is what is trying to explain in the further slide. Let's come back to our slide deck now. Say this. So as you see here, hub and spoke topologies is basically considered as your star topology as well, which is very easy to deploy and less number of connection is needed here. But there is no backup and there is no redundancy. It's not there itself. Now the next type of topologies that we have is full mesh and the partial mesh, as you know that. So full mesh, where all the branch offices are interconnected to each other, which is fully redundant. More connections, complex configurations will be there. When it comes to your partial mesh, basically it is the mix of your star and full mesh. In simple term, when a particular connectivity is redundant for few offices and for one or two offices just one connections, so of course it is going to be your partial mesh itself. So I hope you got the point. We are moving ahead with the next point. Now when it comes to the connections between two different offices itself, definitely we are going to have the WAN technology, as we know that. For example, just take an example here. Let's say this is your one office, this is another office. Consider this is your one LAN segment, LAN 1, and this is another LAN segment, LAN 2. So the distance between two different LAN, if the distance between two different LAN is more, maybe thousands of kilometers itself. So in this case, definitely we are going to take the help of WAN technology itself to connect. But when the two routers are present in the same office, and in this case the distance is very less, definitely we'll be using a special cable to connect between these two routers itself, and this cable known as serial cable or V.35 cable itself. So right now this WAN technology is replaced by this V.235 cable itself. Fine. So we are going to see in our demo, we'll be talking about this scenario itself to understand all of your concepts. Fine. Let's see little more detail about the same. Say this. So see this, when the distance between two router is short, a special cable V.35 cables, which is also known as back-to-back cable, is used to connect itself. Now make sure for the data communications using back-to-back serial cable, one end you will find the DCE and another end you will find DTE. It's all about the cable. This is cable symbol. One end you will find the DCE, another end you will find the DTE, data communication equipment and data termination equipment. DCE is basically going to work like a master. It's going to work like a master, and this is basically works as a slave. This is basically works as a slave. Make sure. Now, when it comes to the master and slave, the point is to remember this is basically going to generate clock rate, bandwidth, the speed it is going to generate, and this is going to accept the same thing. Fine. This is only the point. Now, moving ahead. The serial cable has the special protocols which is used on this. So there is something known as encapsulation protocols. What exactly these are, we'll try to understand. So when it comes to the communications between two different routers by using the serial cable here, there is some kind of protocols works between this. This is basically known as WAN encapsulation protocols. Basically known as WAN encapsulation protocols. Okay. Now let us try and understand what kind of encapsulation protocols are being used here. So first of all, what is the mean by encapsulation here? The process of adding extra header or trailer to the data is called as encapsulation here. And the header and trailer contains the informations which needed for the proper data transportation of your data itself. Okay. Now always remember there are different type of WAN encapsulations you have. As of now, for the serial connectivity you have the PPP and HDLC as the WAN encapsulation protocols. WAN encapsulation protocols we are going to discuss as PPP and HDLC. What is the difference between this PPP and HDLC now? Say this. PPP is basically your point-to-point protocols, and HDLC stands for high level data link control protocols. Now make sure PPP is basically the open standard protocols and HDLC is basically the vendor proprietary protocols. In the sense, basically it's a Cisco proprietary protocols. Open standard in the sense you will be able to configure this PPP in any of the vendor devices. For example, you can configure in Cisco, Juniper, Barracuda, any of the vendor devices you will be able to enable PPP. But HDLC you can configure in Cisco devices. PPP has more features as it supports the authentications. There is no authentication in HDLC. It support the compressions. There is no compressions in HDLC. So what Cisco recommends, even Cisco recommends that go ahead and make use of PPP itself. Don't go for HDLC due to less features and less services. Okay. So we'll be talking about the PPP more and more in detail in our coming lecture, that how you can go ahead and configure and use it. So just a quick introductions when it comes to the configurations of your serial interfaces between the routers. See, the major point to remember here, let's say this is your two different routers. Now the major points to remember is whenever you are going to configure the IP addresses between two different routers, make sure they should be from the same IP address range. They should be from the same IP address range. For example, if I am configuring 10.0.0.1, it should be from the 10 dot range only, like this. This is the general points to remember. For sure you can have different, but you have the different scenario for that. As of now, for the CCNA and CCNP level, your same network is the most popular which we use it. Second thing, when you go ahead and configure the serial interface, you need to remember there should be same encapsulation protocols as well. Same encapsulation protocols in the sense you can use the PPP or you can use the HDLC, but it must be same between the devices. For example, if I have configured PPP here, there should be PPP. You must go ahead and define the no shutdown while configuring this, because by default this port is in shutdown state. So you will have to give no shutdown to this particular interfaces. And always remember, you can go ahead and define the clock rate. Clock rate is nothing but your bandwidth, where you can define only at the DCE side of your connector. DCE in the sense your data communication equipment. Only here you can define the clock rate or speed, which is nothing but your bandwidth. Make sure if you do not define this DTE, generally we do not configure, because by default DCE is configured here and we do not change that. That's the main point. Also, you need to remember, if you are changing the DCE, I mean bandwidth, you need to only change at the end of your DCE only. DT side, you no need to perform any configurations. So this is couple of major points to remember. Same IP address range, encapsulation should be same, no shutdown you need to define, and clock rate should be configured. By default, some clock rate is configured here. Okay, let's move ahead. See the configuration, how you can perform. Don't worry, you doesn't need to think much about the configurations right now, because these syntax will create the problem for you. So I will discuss this in demo session, that how you can configure the each and every statement in detail. So as of now, just remember the points, like you need to assign the IP address and then subnet mask, define no shutdown, define clock rate, define encapsulation protocol itself. And how to verify? To verify, you have the command like show interface brief. Show interface brief, or you can define show IP interface brief is the command to verify your interfaces. We will discuss that later on, how you can define and how you can do that. Now, before going to the loopback interfaces, I would like to highlight couple of major points here. Guys, consider a very simple point. This is, let's say, your router. Of course, yes, in the routers you will find the ports. What kind of ports you will find? See, there is two different type of ports you will be getting. You will be getting the physical ports or physical interface, and second you will be getting the logical interface. Logical interface. When it comes to the physical, you need to remember, you have like serial interface, you have like Ethernet interface, you have like console interfaces, you have the physical one. When it comes to logical, physical in the sense where you can touch, you can feel, and you can see that. And always remember, the physical ports may defective, maybe your physical ports get damaged due to some reason. But when it comes to the logical interfaces are nothing but it's a virtual interface, and virtual interfaces never goes down until your router goes down. And this virtual interfaces you can use in many scenario for sure, in the real time as well. But right now we are going to use this loopback interfaces as the virtual interface just to test some of the functionality itself. Okay, so make sure physical interfaces has the separate things and logical has the separate value. And this logical interfaces are basically your virtual interface, which is known as the loopback interfaces, in Cisco. Okay, let's see the detail. See, a loopback interface is basically a virtual interface that resides on the routers. Make sure your loopback interfaces are very useful, because they will never goes down unless your entire router goes down. By default, a router has no loopback interfaces here. Loopback interfaces are not enabled by default, that's what. But they can be created easily based on our requirement. So the simple point, Router has the logical interface known as loopback interfaces. By default, loopback interfaces are not available. You can create the loopback interfaces easily, and you can use this loopback interfaces for some of the testing purpose or some of the real-time purpose as well. How to enable loopback interfaces? See this. It's very simple point. See, interface loopback and then loopback number like 0, 1, 2, 3, 4, 5 something, and then you define IP and then IP addresses to this. By default, your loopback interfaces are in up state. You doesn't need to define any kind of no shutdown command here. So this is enough for this particular lectures. We'll see you in the next lecture with the demo that how you can configure your serial and loopback interfaces. Thanks everybody. See you in the next lecture.